Hello, everyone, and welcome to a Minitab episode of Fun Times and Statistics. Today I'm going to be talking about the goodness of fit test and, well, one of my favorite subjects, candy. If you're looking for this document, you can find it just below this video, a blank version, which you'll need to fill out yourself. So, our first little experiment involves using M&Ms. Now, you can repeat this experiment using any type of M&Ms. I have the percents by colors for different flavors listed below the example, but I just went and bought the plain ones because that's what I could find easily. Anyway, so unfortunately, M&M no longer has the color proportions listed on their website. They used to keep a running total of what the percentages were. I did some digging, was able to find an older version of their website that still had them up here so that you don't have to dig yourself. Here they all are. So we're just going to look at the current candy values, and that's their claim that really the proportion claimed by the candy company is that 13% are brown, 14% are yellow, 13% are red, 24% are blue, 20% are orange, and 16% are green. So what I did is I bought a bag of M&Ms and I painstakingly separated all 209 of them, and these were the counts for my colors. So I just went and counted how many green I had, how many blue, how many orange, how many red, how many yellow, how many brown, and then recorded them below in this little table. So what we're going to do is we're going to perform a goodness fit test to check the manufacturer's claim. So the first thing I'm going to want to do is I'm going to set up my null and my alternative hypotheses so that I know what I'm testing. And I sort of gave this away. We're going to be doing a goodness fit test because you're testing to see, did the bag I currently have match the historically listed proportions from the candy company? I'm going to pause this first. So my null hypothesis, HP, is going to be that the distribution of colors is as the manufacturer claims. And then my alternative would be, well, just not that. So the distribution of colors is not as the manufacturer claims. Okay. So in looking at this, I have to watch out for a couple of things. The next thing I should do is I should check myself before I wreck myself. So I check my assumptions. So the first thing you got to ask yourself is, are my bags of candy independent? Probably. Since there are 209 candies, I'm probably good for the at least 5. So, well, the first thing you should do is this categorical as this counts? Yeah, I mean, I count them myself. Yes. Next up, you would ask yourself, are there at least 5 of them in every category? Yep. I mean, my lowest one is 29. So at least 5 for each cell. Yes. And last but not leastly, I should be checking, is this random or independent? I mean, it's probably all manufactured in the same factory, but not all bags are probably coming off the same production line. Or maybe they all are. There's probably no way to actually know this, but they're probably producing enough candy in a single day even to meet the 10% condition and to have it look at least kind of random. So I'm going to say yes to randomness and yes to this not being more than 10% because otherwise they only make like 10 bags of candy a year, which is 100% not true. So, sorry, yes, less than 10%. I could probably do a couple bags of M&Ms and still end up being less than 10%. So if you want to increase your likelihood of getting an accurate representation here, you probably do more than just one bag. Anyway, so now that I've checked my assumptions, let's go ahead and do this. So I'm going to do this in Minitab. So I'm going to pull that up real quick. I'm probably going to delete this later. Maybe not. Okay, so couple things. I have to type this in, so I got to type in my candies. So I'm going to go ahead and start typing that now, and I'm probably going to pause this and then update you when I have all of it in so you don't have to watch me. Okay, and we're back, and I have typed in my color codes and my counts. If you wanted to, you could have just put these as the counts. But for what I'm going to do with the goodness of fit test, you can, I want them labeled because it makes it easier on me for the next part that we're going to do. So to do the goodness of fit test in Minitab, we go up to Stat and down to Tables. All of the chi-square tests are found in the Tables area of Stat, so be careful. The one variable test is what we're looking at, the chi-square goodness of fit. So you're going to go ahead and click on that guy, and he's going to come up. He has a really big menu, which I find kind of annoying, but you get the idea. So the first thing I want to do is put in my observed count. So this is coming off of my sample, which I labeled count, and then my category names, which are the colors. And I want that because down here in this radial button option, there's the option to put in specific proportions, equal proportions, and then proportions specified by historical counts. That's the one I want. And I'm going to input the constants myself. So it brings up my colors automatically, which is nice. So now I can just type these in. Let's see, where's blue? Blue is 0.24. Brown, I'm gonna move this down. Where's brown? 13.13. And then green. Oh, this is so boring. I'm gonna fast forward through this, or maybe cut this part of the video. Or you can just listen to me talk to myself. What's my favorite color? What's yours? Mine is not red. Red looks terrible on me. Yellow looks good on nobody. I look like a big stick of butter in yellow. And we'll hit OK. All right, this produces lots of stuff for you. The first part is this contributive value section. I'm going to just go ahead and ignore that because we don't really need it for what we're up to. The next thing you might want to look at is a chart of observed versus expected. This is kind of useful, especially since if you notice, one of the things I didn't do here is I use the proportions for my expecteds. I didn't use the actual counts. If you hover on this, it'll actually give you the value for the observed and for the expected. So it's calculating the number or count for you based on the percentages you put in there. So if you actually wanted the counts for the expecteds, you would use these values. It also produces those over here. So there's the observed counts, the proportion that I historically inputted, and then the expected that goes with those, and then how much they contributed to chi. So they took the observed minus expected, squared it, divided by expected, and that's where these values are coming in. And then it added them all up. And look how big my p-value is. Ooh. Okay, so I am definitely headed towards failure to reject for this. It appears that the distribution is just as the manufacturer claims. I should say the evidence, because that's what's going on. Supports the manufacturer's claimed proportions for each color. So, turns out M&M wasn't lying to us. Are you surprised? Maybe. Okay. Let's do another example, not involving colors. So I wanted to show you how this looks for a different type of selection menu for the goodness of fit test, because there were some other menu options that I didn't select. So let me space this out a little bit. Please delete this when you're done, teacher lady, woohoo-hoo. Okay. So this question is a little bit more on the traditional side to what we're used to. Why does I always want to justify everything? It's super weird. Anyway, so we have 4 categories, A, B, and C, and D, and we assume the percentage in each category is equal. So I'm assuming you're equally likely going to get an A, B, C, or D for these groupings. So as you look at this, you should be thinking, oh, we're assuming equality across, we're assuming a uniform distribution, and then we gather information to see if those are reflected in our sample. So we take a sample of size 500, and we find 100 category A's, B's are 140, or 100 also, 140 in C, and then 160 in D. So which chi-square test is appropriate for this situation? Well, when it comes to equal spread across one variable, aka one categorical variable with 4 categories in it, the only one that's going to fit is goodness of fit, because we don't have a second variable. So this is going to be the one we're going to use. The other thing you should ask yourself is, is this fitting my assumptions? I don't know a whole lot about what's going on here. I only know that the sample was drawn and has a large enough size. I don't know if it's random. I don't know if they're independent. I mean, you really, it's kind of questionable here. This is a very short example, so there's not enough detail for you to say, yes, it's appropriate. So ideally, you should ask more details about how the sample was gathered, to be sure that you fit the assumptions of the test. Woohoo! Okay. Oh, zooming in, not fun. And again, I lost my coloring. What are you gonna do? Okay, so now we're asked what are the expected frequencies for each category, and this is where I need Minitab to help me. So I'm gonna go over here, pause this, and type in what I need. And we're back. Okay, so I've typed in over here the amounts from our sample. So the 100 for A, 100 for B, 140 for C, and then 160 for D. I named this cats because we don't know what categories this came from. So this is like, I don't know, things. And then I called this counts because I can't call it count. I call this one count. And I'm using the same Minitab spot. So I want to figure out the expected values for this. That's going to come off of doing the chi-square test. So we're going to actually do the goodness of fit for chi-squared right now. And that will give us all this output that we need in order to answer this question. So we go up to stat, tables, and down to the goodness of fit test. So it's still using my previous values. I'm going to change this because now I want counts, the one I just made. And then for the categories names, I want cats. And then it's going to say, oh, well, these are the values you want, right? Nope. There's this option to assume equal proportions. And that's the one we want because we're assuming each category is equal. So we're assuming they're all equally likely. This would be saying that, like, I'm assuming that my sales come from all four product types or something like that in equal measure. They're all pretty much equal. Okay, so I'm not going to specify anything else about my results. I'm just going to go ahead and hit OK because the defaults for chi work good enough. Yawns. I don't even like looking at this graph. I don't even care. No. All right. That was way dramaticer than it needed to be. So I am going to grab this information here from the output from Minitab and then just go ahead and use it to make what I need. Ta-da! Okay, so I don't need this observed. Oh, this is going to be awful. I only need the expecteds. Where is it? 125 right there. Okay, well, I guess I could have just typed this and gotten better results. So, ready? Look over here. Here's your category. And then expecteds. So, you could look at this and say, like, oh, well, what's this going to be? Well, for category A, it's going to be 125 because I'm assuming these are all equal and there's 500 of them. So you could have calculated this without Minitab, but I did it with it just in case you run across one where it's a little bit more difficult than just 4 groups. So there's that. So these are my expected counts. 125, 125, 125. I should have made that a lovely table. Oh, well, too late now. Woo! All right, so the next thing is we need our chi-square test statistic. So where is that guy? Where is he? Oh, right there. He's 21.6. That's pretty big. This is going to be one that probably comes out as a failure to reject because that's, or no, not failure to reject, a reject. Large chi usually is a rejection. Oh, look, my p is like really small. Okay, so let's write our lovely statement of rejection. Get excited. We are definitely rejecting our null. Okay, so what does this mean? Well, our assumption is that they're all equally distributed, which means they're not. So one of the ways you could say this is oh, I'm not typing on here. Why is that not working? There we go. The evidence suggests that the distribution is not equal across all the categories, whatever they happen to be. This is why I like statistics, because usually when we're doing this, I'm like, oh, it's the, sales divisions or the regions of the country that I do business in, or there's context usually to the numbers. So I actually hate this question a little bit, but I kind of wrote it in a hurry. What are you gonna do? So really, it's saying that it's not equally distributed. So it appears that one of those groups is probably larger than the other or just different from the rest of them. And you can't tell which one is larger because you may look at this and be like, oh, well, 160 is the biggest one. That's what it is. Okay, fair enough. But this one's 140, which isn't far off. So these both might be significantly bigger than A or B. Or it might be just the fact that C and D are similar and A and B are similar. In which case, saying, oh, this one is bigger is kind of useless. You really didn't say much about how the distribution looks. Anyway, you should never use samples to say things absolute about a population. And I'm hoping we're learning that. All right. That's all I have for you for these two examples. So here's two examples on how to use the goodness of fit test in Minitab. Hope you enjoyed.